Thank you. Descriptive statistics provide a way to summarize and describe the essential features of a data set, quoted by Daniel. A very good evening to one and all present here. I am Vachinius from First MCOM. I now request Dr. Vidya, faculty, Kristu Jayanti College, Autonomous, to welcome the gathering. Over to you, ma'am.
Our greatest weakness lies in giving up. The most certain way to succeed is always try just one more time. Thomas Alva Edison. Good evening to one of our present here. I, Dr. Vidya, on behalf of Department of Commerce, PG, take this opportunity to welcome Dr. Sinimole K.R, Area Chair Business Analytics, Rajagiri Business School, Kochi. She is the speaker for the day. We are delighted to have you with us, ma'am. I also welcome Dr. Madhu Kumar, Head, Department of Commerce, PG. We welcome you, ma'am. I also welcome the FTP coordinator, Dr. Chidlin Thomas. And I also extend a warm welcome to my fellow colleagues, Dr. T.K. Murugesham, Dr. Pushpa, Dr. Mohan Kumar. Your immense support is making this FTP into a reality very. A hearty welcome to the participants of this FTP. I'm sure the last 3 days of FTP have given us a central grip over the field of business analytics. The first and the second year of Income and Income ethics students have joined the first. We cherish your presence, dear students. Last but not least, I welcome all the tech team for this support. Thank you. I will over to you, Ashwin.
Thank you, ma'am. We welcome you as well. Without further ado, I now call upon Jeevita to introduce the resource person of the day. Over to you, Jeevita.
Thank you, Varshini. It gives me an immense pleasure to welcome today's resource person, Dr. Sinimole K.R. Dr. Sinimole K.R. is a graduate in mathematics from Mahatma Gandhi University, Kerala, a postgraduate in operations, research and computer applications from Kochi University of Science and Technology, Kerala, and earned PhD from Tata Institute of Social Sciences, Mumbai, for a research paper titled A Study on Hospital Performance, Role of Management Practices and Patient's Perception. Ma'am has completed predictive modeling using R programming language from the Indian Statistical Institute, CMI Level 5 Certificate in Management and Leadership from Chartered Management Institute, London, Bayesian Statistics from Concepts to Data Analysis from the University of California, and certification course on Data Science Methodology and Tools for Data Science from IBM. Ma'am's teaching interests are focused on the areas of business analytics, applied business analytics using R and Python, operations research using Excel, and QM for Windows software, business statistics using SPSS, Excel and R, decision science and research methodology. Ma'am has received AICTE UKIERI certificate on Technical Leadership Development Program in 2019 and Dr. Sharat Joshi Outstanding Management Research Paper Award instituted by Samshodhan Trust, Pune in 2012, and chaired the 4th Rajagiri Management Conference jointly organized by Rajagiri College of Social Sciences, Rajagiri Business School, and Johannesburg Business School, Johannesburg. 17th and 20th AIMS International Conference on Management, jointly organized by AIMS and Indian Institute of Management, Pune. Ma'am has published 15+ research papers and presented various papers at international conferences. With 20+ years of teaching experience, Ma'am is currently working as an associate professor at Rajagiri Business School, Kochi, and is also visiting faculty at the School of Management and Labor Studies, Tata Institute of Social Sciences. She has a lifetime membership with Indian Institute of Industrial Engineering, AMII. We are privileged and honored to have you with us as a resource person, ma'am. I now request you to kindly take over the session. Over to you, ma'am. Thank you.
Thank you. Thank you so much for such a long introduction. Let's start with. Can I share my session? PPT?
Yes, sir.
I hope the PPT is visible to all of you.
Yes, yes, sir.
So let's start. Good evening, everyone. Today we are going to explore descriptive statistical measures. That's a vital tool in the world of data analysis and decision making. Descriptive statistical analysis serves as the cornerstone for summarizing, presenting, and organizing data in a meaningful form. So we are trying to explore the significance of each and every measure there in descriptive statistical analysis. Because understanding these measures is very crucial as they are the base towards the future research or the further statistical analysis. So we can consider descriptive statistical measures as a lens through which we can gain insights about the data characteristics, the distribution of the data. So today, we are going to understand each and every measure and its specific purpose. And basically, the measure specific purpose, they start from the data analysis. That means the nature of the data and the analytical tool which we want to use. Okay, today we are going to see scenarios in which these specific measures are applicable. And I hope this session will help you to understand the descriptive statistical measures in a better way. Having said this, let's start with. So as I already said, descriptive statistical measures are the first step towards the statistical analysis. Let's start today's lecture with a story. See here, a person wants to cross a river. Okay, he was unaware of the depth of the river, so he did a little research and he understood that the depth of the river is 160 centimeters. So he was so glad to know that because his height is almost 175 centimeters, he thought that all the time he will be above the water. So he happily started his journey. But at the beginning, the level of the water was very shallow. And as he reached the middle of the river, the water depth is around 500 centimeters and he lost his life. This is the way basically we start with our data. Many of us start with our data analysis. We misunderstand the concepts or maybe we misunderstand the measures and then we start using some of the measures which are popular or some of the measures which are common and then we end up in a wrong analysis or wrong model which will not help us in any way. Okay, so basically we need to understand the measures in a little different way. So which measures to choose? How do you understand that? So basically when we start with descriptive statistical measures or statistics as a tool, we know that the descriptive statistics is broadly divided into descriptive statistics and then inferential statistics. Today we are not going to deal with inferential statistics. We will go deep into descriptive statistical measures. Okay, so as all of us know or already you said, the descriptive statistical measures are the values that describe the data, the characteristics of the data, and it helps us to summarize, describe, and characterize data. It helps us to determine whether the sample is symmetric, sample data is symmetric or asymmetric. It gives us a quick glance to the central tendency and the degree of dispersion. It helps us to understand the data distribution. It helps us to understand, compare distributions or compare group-wise data distributions. So if you go through the numerical data properties in a quick way, so let's understand that numerical data properties, if you deal with basically central tendency is there, measures of dispersions are there, and shape of the data. These are the basic things. And as all of us know, in central tendency, the basic things are mean, median, and mode. And in variation, range, interquartile range, and standard deviation. And shape of the data deals with skewness and kurtosis. So, as all of us, I agree that all of us know these measures. We have studied it from the school level. We know how to calculate mean. We know how to calculate all these measures, and just a quick glance through. Let's go through the measures once in a quick way. So mean, as all of us know, it's sum of all the observations divided by total number of cases, and is the most common measure. It's act as the balance point. It does not ignore any of the information. That's the plus point, but it's affected by extreme values. Median is the middlemost item. It is not affected by extreme values. It doesn't take any actual value into account. That is its drawback. Mod, if you look at, that is the value that occurs the most. It's not affected by extreme values, but it ignores most of the informations in the distribution. Sometimes we may get one mod, no mod, or no more than one mod. And quartile measures, if you look at, we have 25th percentile as Q1, 75th percentile as Q3. And standard deviation is the measure of how spread out the numbers are from the central or the mean, arithmetic mean. Range is the difference between the highest and the lowest, and interquartile range is the difference between first quartile and the third quartile. These measures we have seen a lot many times. We always calculate it. We always use it. So we know the calculation. We understand that within a click, with one click, you'll get within a second of time, you'll get all these measures in your hand. But how do we utilize it? So when and where to use mean, when and where to use median, and when and where to use mod. That's what we're trying to see first. So let's take a scenario, a thinking challenge. Here is a scenario. In an organization, there are certain employees with the distribution of pay this way. Okay, so employees always cite low pay. So they complain that the pay is low. But the president claims that the pay is 70,000 rupees. So what is wrong with? Is the president's claim wrong or the employee's claim wrong? Who is claiming wrongly? How do we understand? Or is there any problem with the data? So what is wrong with the problem? What is wrong with the data? How do we understand? So next, again, second challenge. So let's assume that 7 students of my business analytic course scored the following marks. Their marks are like this. Okay. And as a faculty, I claim that A students score 43.14. So that means all the students are passing. 40 marks is the passing out 100. So all the students are passing. So what is wrong with the claim? So am I claiming it rightly? Or what is wrong with the data? So how do we understand? So which measure of central tendency can be used in such cases? How do we understand that? What is the problem? Where exactly is the problem? So here in this scenario, if you look at, we are trying to compare two things which are not comparable. That means it's just like comparing apple with orange. So basically, the problem with the data or problem with such situations is skewness there in the data set and outliers there in the data. Skewness or outliers, these are the two things which we have to understand. So what is skewness? How do we understand skewness? Skewness, all of us know that it refers to data set. Skewed data means the values are not evenly distributed. It's causing the frequency of occurrence to lean towards one side of the distribution like this. That means either towards positive side or towards the negative side. Okay, so if you look at the first graph, the data is skewed towards the left, right, and the second graph, the data is skewed towards the left side. So here, if you closely look at, the central measures are not seen here. Mod or median or mean, if you look at the first graph, positively skewed data, mean value is more than the median. And if you look at the second data set, mean is lesser than the median value. So whenever your arithmetic mean is greater than median, if it's not equal to the median and it's greater than median, we say the data is positively skewed. That means there are certain numbers which are higher than the central value. Or if you consider all other values, some values are away from the group. Similarly, negatively skewed data, some values are lesser than all other values. So these two situations, if you consider, we say that the data is skewed. So what is the problem with skewed data? So before we go into the problem with the data, or else before we understand it using the examples which we have already seen, let's see how a data which is not skewed or a symmetric data look like. A symmetric data, if you look at this graph, this is a bell-shaped curve. In a symmetric data, you can see that mean, median, and mode coincide. That is a central line. Okay, so the central line divides the data into two equal halves. Okay, 50% of the distribution is on one side, the left of the central line, and 50% of the observation is above that. Okay, so mean, median, and mode coincide for a symmetric data. It has a bell-shaped curve, or in statistics, we call it as a normally distributed data. So this is the way it is. It has both the tails balanced. So this is the symmetric data, or this is the way we actually want the data. So whenever we start with a model, business model, or whenever we start with an analytical model, we need to explore the data, or an exploratory data analysis. Firstly, check whether the data is symmetric or not. Because many of the analytical models, or even many of the statistical models, they need a normally distributed or a symmetric data set for analysis. Otherwise, certain statistical measures we cannot use, or we need to treat the data and make the data in a usable form. So this is the way we can understand whether the data is symmetric or not. So here, if you look at the three things together, symmetric data is in this form, and positively skewed data has a tail towards right, and negatively skewed data has a tail towards left. And another thing is that I have given another plot here. This plot, which is below here, the symmetric data here, it's known as a box and whisker plot. So how does it help us to understand whether the data is symmetric or skewed, or positively skewed or negatively skewed? This is the easiest measure which we can rely on or depend on in order to understand the distribution of the data. So let's have a quick glance through what is a box and whisker plot all about. If you look at the diagrams here, box and whisker plot is in this form. Here, it always gives us 5 number summary. That means the minimum value, it talk about the maximum value, it talk about the first quartile, third quartile, and the middle value, that is median. These 5 numbers are summarized there in a box and whisker plot. Okay, so what is the importance of the box and whisker plot? How does it help us to understand the distribution of the data, and how does it help us to understand whether the data is skewed or not skewed? If you look at the box and whisker plot, either it can be put it in a vertical form, or it can put it in a horizontal form. All the statistical softwares, they give the vertical format, and that is the one which is basically used. So for explaining purpose, I have put it in a horizontal form. Here you can see that there is a box and there's 2 whiskers. Okay, so inside the box, if you see the 25% inside the if you look at the box starts from Q1 and ended at Q3. So that means there's a box between the first quartile and third quartile. So what is the importance of this box? Basically, this box contains the middle 50% of the observations. Just like your normal distribution curve, so it within one standard deviation, if you take from arithmetic mean, it contains almost 68% of the observation. Similar to that, here the box and whisker plot, box contains middle 50% of the observations, which are close to the central value. And if you look at the tail, so there's a positive right tail, which contains again 25% of the observations, and the left tail also almost 25% of the observations are there. So the first simple thing which you can understand is that, so suppose if you have a performance data and you are putting it in a box and whisker plot, you can see that this 25% or this side, the left whisker, is the group of people who have performed low. Okay, the low performers are in this the left whisker, and the high performers are there on the right whisker. And the middle of the box, the middle box or the box contains exactly what the average performers. So we can consider 3 groups here accordingly. The maybe the HR can plan activities. So the simple way to understand is that the box is the important part where you get without any outliers or without any extreme values, the middle 50% on the important aspects of the distribution. So here, box and whisker plot, apart from that, it helps us to understand outliers also. If you look at, when you go for a box and whisker plot, if you get a dot like this, that means it is an outlier. So outliers are easily described there in a box and whisker plot. That is another important aspect of box and whisker plot. It helps us to understand the outliers easily. Okay. Now, if you look at box and whisker plot of groups, okay, here there are two groups, say A and B. If you look at the box and whisker plot, it helps us to easily compare the groups. So before we start with any kind of statistical models, for example, before we start with the two sample independent two sample t-test or ANOVA, we need to see whether there is a variability or this group wise difference is there in the data set. So if you look at the box plot of those measures, you can easily understand is there a difference in the group. Here, if you look at this two group, you can easily say that group A has a higher median line than group B. See, the entire values of group A is higher than group B. So the difference is actually large. So the median value of group A is much higher than that of group B. And so it helps us to understand the central tendency. That means the central value. What is the central value? Is there a difference between the central value? Can be easily understood using a box plot. Next important thing is that it helps us to understand the variability of the data. That means if you look at this two box plot, the first one, the box is small, and the second one, the box is bigger. Okay. So, and if you look at the tail of the second one, the tail is also large. Okay. That means that group 2 has more variability than group 1 because it has a longer box and whiskers. So variability or spreadness there in this group 2 is much more than variability there in the group 1. Okay. So that is the next thing which we can understand from a box and whisker plot. And apart from that, you can, as I already said, box and whisker plot can be used for understanding the skewness. If the central line in this box, that means the median line, is closer to Q1 and the tail, the upper tail is longer, that means it's a right skewed distribution. The distribution is right skewed. Similarly, if you look at the lower tail is what you call long and Q median is closer to Q3, that means it's a left skewed distribution. So easily looking at the box plot, you can understand whether the data is skewed or not. Next thing is that let's go for the thinking challenge which we have put. Okay, so here we have seen that we have a claim of 70,000 from the president, and the employees say that it's not like that. So how do we understand this situation? How do we say whether the claim of the president is wrong or not? So first thing is that we need to plot this data in a box plot. Okay, the simple way to understand is that just go for a box plot and see how the distribution of the data is. So if you look at the data values are here, and I have plotted it in a box and whisker plot. Okay, so here the box plot, if you look at even the tails are not even seen. Okay, only the box is there, and there's a dot here with 4 lakh as a value here. It simply means that 4 lakh is an outlier in the data set given. Okay, and here if you look at the box plot gives us a smaller value, the Q1 small value, the minimum value, and Q1 here both the things are one and the same. And median is 30,000, the upper quartile is 70,000, and mean is also 70,000. So that is the reason the president claim is an average of 70,000 is there. So that is a wrong claim, or that is a problem with the data. That means there is an outlier on the positive side. So because of that outlier, the average has gone up. That is why he is getting an average value which is much above all other values. Okay, so whenever you have an outlier like this, or the data is skewed towards positive, negatively skewed, or positively skewed, so then average is a wrong concept. So then you cannot depend on average as a measure of central tendency. That is the maybe learning from this example. Similar to this, the second example also is in the same direction. So the students' mark, if you just plot it, see here, mostly the students' marks are with say below 40. If you draw a line here, you can see that most of the students' marks are below 40. And there is an outlier here. See, the one student who scored 99 is an extremely performing student, or maybe he's an odd man out guy, or else comparing with the other students, his performance is much above others. Because of that one guy's marks, the what you call the average mark is gone up. That is the reason the faculty could claim the average is 43.14. So the students are scoring better than the other students, or else all the students are passing. So here, this is a box and whisker plot of that material, that same data. Here, if you look at the lower whisker is seen, but you can't even see the upper whisker because the high value, the outlier is much above all other values. So this is the way a simple box and whisker plot help us to understand whether skewness is there in the data or whether arithmetic mean can be used in such situations. So arithmetic mean is not a good measure in such places. That means whenever data is not symmetric, or if the data is left or right skewed, do not attempt or do not go for arithmetic mean without treating the data. So in such cases, we can opt for median, which is a better measure than mean. So here, there's another example which I'm trying to give you here, that is about the sugar utilization in a soft drink manufacturing company. So here, if you look at the graph, mean and median, here the mean value is 219 and the sugar utilization median is 218, and the median line is mostly at the center of the box. So here you might be able to consider this data as slightly symmetric, or we might be able to consider arithmetic mean as a good measure in such cases. So as a thumb rule, we can say that if the data is symmetric or normally distributed, mean is an option. When the data doesn't follow a normal distribution or it's not symmetric, then median is recommended. If extreme values exist, mean might be heavily impacted by outliers, making the median a more reliable measure to represent the central tendency. So box plot in such cases are helpful in visualizing the spreadness and skewness of the data set. Removing or addressing these outliers is at most necessary before we consider further statistical analysis or any kind of statistical analysis using arithmetic mean. You need to treat the outliers or you need to address the outliers before that. So now, apart from this, box plot also can be used for comparison. That means comparing the distributions. So let's take an example here. See here in the Bangalore city, a survey is conducted in Bangalore city about the housing prices. Okay, so these are the five cities which are considered: Whitefield, Hoscote, Airport Road, Bellatore, and Marathali. Okay, so if you look at the box plot, what all things can be understood? The first thing is about the centrality. So that means the central line represents the median value, and the houses on Airport Road have a highest median. How do we understand? Here is the airport one. Okay. So the airport, the graph or the box is much above the other thing. So the median line of the box here, if you look at, it's above all other values. So we can say that, which make it a comparatively expensive place. The Airport Road houses or the housing is expensive in Airport Road, whereas houses in Marathali have the lowest median value, which allow us to conclude that houses here are relatively cheap. See here, if you consider this one, the median value is the lowest here, and you can say that the houses are cheaper than all other places here in Marathali. And second point you can understand out of this is about variability or the spreadness of the data. The Whitefield and Hoscourt areas have same median. If you look at Whitefield, he is here and Hoscourt is here. The median line is same. But if you look at the data distribution, this Hoscourt, the box is longer than, or maybe what you call wider than this box. Okay, so that means spreadness in the prices. If you look at Hoscourt, prices are varying more than Whitefield, but Whitefield prices are mostly uniform, or else it's what you call the variation in the prices in Whitefield is lesser than variation in Hoscourt. As altogether data of 5 cities, if you consider, the variation in prices is much more in Bengaluru here. That means in this place here, both type of houses, that means what you call all type of ranges there, high priced housing is there, low priced is also there, therefore what you call, so this, the variation is much more in Bengaluru. So it's an indication that all sort of housing you will get in that particular place. But if you look at the airport road, the housing is what you call, basically it's towards the upper side. So that is the second part, that is variability or spread. That is what we can understand from that. And one more thing is what, it's about the symmetry. Okay, symmetry around the median, talk about the skewness. Okay, if you look at the plot Marathali, the median is towards the lower half. So we can say that it's right skewed, which means that most of the houses are on the cheaper side and only few are expensive. So here, if you look at, see here, this median line is towards Q1, so it's positively skewed. So mostly the values are towards the lower part and very few values are towards the upper side. So the houses are mostly cheaper here, but some houses are expensive too here in Marathali. Okay. So that is the third point which you can understand out of the comparison of box plot. And next is about tail length. So if you look at the length, it talk about the kurtosis present in the data. So here we can go for 3 cases. Either your data will be normally distributed or will have more data in tail as compared to the normal distribution, might be platycardic, or will have fewer data in tails as compared to normal distribution, maybe it's leptocardic. Okay, a long tail shows that the distribution is platycardic, and a short tail should tell us that it's leptocardic. So in the earlier example, Marathali has a shortest tail, so then we can say that most of the house price lie in the interquartile range, say Q3 to Q1. So this is the one. So apart from understanding symmetry, now we can understand outliers also, that we have already seen. And as I already said, for the statistical testing, so suppose if you want to go for ANOVA or t-test box plot, or looking at the box plot, we can have a quick understanding whether we need to go for ANOVA or t-test. That means, is there the group wise difference is much more or not? Easily it could be understandable looking at the box plot. And it can also help us to identify the trends and patterns there in the data. So this another example, I think maybe I will leave the slide with you so that you can look at. This is about the students' marks for statistics, business communication, economics, marketing, and HRM. So here also comparison in the same way is possible. Okay. Now here, how do we get a box plot done? So quickly, let me now connect to the Excel sheet so that I'll give you how do we understand, or how do we get an Excel box plot done. So let me connect to the Excel sheet. So let me take an example here. Okay, so here I have taken the scores of the students. See, scores start from 63. I think 20 students scores are there. So this is my data set. Let me choose this data first. And so in order to insert, in order to create a box plot, it's very easy. Go to insert mode. Go to insert, and if you go to the recommended charts, see in there in all charts option, there is box and whisker plot. There's an option, box and whisker plot. Click on it and then OK. So your box plot is ready here. So you can change the chart title, or you can, if you want the data labels, the mean value, median value, the upper quartile or the lower quartile. So click on the data labels option and then add data labels. All the values are here. Okay. So, and if you don't want the lines here, you can. Okay, you can give the chart title and everything. So it's very easy to create a box and whisker plot there in the data using Excel. Similar to that, if you want to create a comparison, okay, that means instead of a single box plot, you want to have a comparison of different things and you need to get a comparative data box plot. So here, so my data values are arranged in that groups. So the students marks are here, statistics marks, all such things are there. Statistics, communication, economics, marketing and HRM marks are here. So select those marks, go to insert, recommended charts, all charts option, box and whisker plot. The graph is ready here. See, it's easy for us to create a box and whisker plot. You don't need to go for any kind of statistical softwares, that mean SPSS or R or Python, for understanding the distribution of the data or the descriptive statistics of the data. Excel itself is powerful nowadays, so it gives you almost everything. Okay. So Excel starting option is very easy. You don't have to choose the variables. So select the variables and put accordingly. Just choose your range, whatever you want to plot, and then go for the insert option that gives you all these things. Okay. And apart from that, in case if you want to get all the measures in Excel, you can have data analysis toolpack of data. Okay, you can make use of data analysis toolpack. And in case if you don't have the data analysis toolpack, you can get the toolpacks, data analysis toolpacks in add-in. Okay, go to and configure data analysis toolpack. So here is my data analysis toolpack. So if you look at data analysis toolpack option, there's an option for descriptive statistics. It helps us to get the descriptive statistics of all kind. See here, the input range it asks for. Just choose the, suppose I want the descriptive statistical measures of my statistics scores. So choose that, and here which measure I want, summary statistics, and just click OK. If you can see that all the statistical measures are there. You don't have to separately calculate it. Mean is there, median is there, standard error is there, mode is there, standard deviation, kurtosis value, skewness, all such things. Now, if you look at the skewness value, it's 0.36. Basically, when you go for data modeling and all, if the skewness value is between 0.5 or maybe within a range of 0.5 from a 0, that means minus 0.5 or plus 0.5 towards the right or left, then we say that such data can be considered as normal or the skewness is very less. So we can think about arithmetic mean as a central measure and corresponding hypothesis testing, or maybe corresponding modeling can be done. And if skewness is beyond 0.5 on both sides, we consider those data set as skewed, either towards left or right, depending on the sign. Similarly, kurtosis, if you look at minus 0.3 to plus 3, we consider it's mesokurtic. Otherwise, either it's towards the left or either it's platykurtic or leptokurtic. So it's descriptive statistical measures is very easy there in Excel. So the visualization part is easy, as well as getting the measures is also very easy. So let me stop sharing the Excel sheet now. So let us go back to our the PowerPoint presentation. Just a minute. Let me share it. Yeah. All right. So that is what we have seen now. We understood that if the data is not symmetric, we can't actually think about arithmetic mean as a central measure. Okay, now that is what we have seen. I have given how do we get the data analysis toolpack and how do we get the descriptive statistics here. You can have a look at it later. Now, next example which I want to discuss here is about categorical data. See here, if I look at these values, how do you understand the most liked flavor out of this? Here, the manufacturer of ice cream, he wants to choose the most flavored ice cream or the popular flavor from the ice cream set. He conducted a survey among the 100 people and they were asked to choose the most liked flavor of the ice cream. And that means the flavors given were chocolate, vanilla, strawberry, and peach. After conducting such a survey, he got the observations. That means 100 people have given their liking. Okay. So how do we analyze the data? Can we use mean, median, or mode for such a case, which is applicable here? So arithmetic mean, so that means there are 4 things: chocolate, vanilla, strawberry, and peach. Can we go for arithmetic mean, or can we go for order? And can we say median is the option here, or is it mode? How do we understand? So what I did is, after getting the data, so I have just created a table out of or frequency distribution out of this. I'm trying to understand the distribution here. If I look at the thing, chocolate, 45 people have said yes, they like chocolate, and peach is by 19, and strawberry is liked by 25, and vanilla is liked by only 11. And if I plot it, you can see that 45 is the highest one. Okay, 45 is the highest frequent or highest occurring item here. So in such cases, if categorical data is there with us, or in such cases, we say that our mode is better than arithmetic mean or median, because the data is categorical. It's not in numeric form. So in such cases, mode is a better choice. So we can say that here in this case, 45 is the 45 is the number, or else we can say that the most flavored brand or the most flavored thing, most liked flavor is the chocolate. Next, there's another example here, similar to that in our classrooms and everything. So let's assume that there are 4 labs here in RBS, Rajagiri Business School, and I want to conduct my lectures in one of these labs. For the next trimester, I asked my students which one they prefer. So they have given their preferences this way. So here also, if I look at, students have given preferences to 401 much more. So that means here the model value is 401, or else you can think that this is the central value here. This is the most preferred one. So in such categorical cases, we can opt for mode rather than median or mean. Now, again, another case, if I look at, see here, I want to consider shoe size. Always, whenever you look at mode always can't actually give you the right thing. Sometimes it creates some kind of problem. So it get us into trouble. Let's consider another example here. A shoe store, he wants to understand the most popular size. Okay. So he has done a survey for 500 people of 500 pairs of shoes. That means he was recording his data and then he marked the size of the shoes. At the end, he understood that size 8 is the mode as it appears more frequently than any other shoe size. But 9 and 10 also come close runner-up, as a close runner-up, each with 120 sales. And can we consider only 8 or size mode, or should we recommend the storekeeper to keep only 8, size 8? Can we do that? Because that is the model value, or that is the central value, that is the one which is most frequently gone. Does it mean that? No. Why? Because that is most occurring, that is the most frequent item, that is right, but if you look at S9 and S10, or size 9 and 10 is also there, almost there with 120 sellings. So that means in such cases, we can't always consider model value alone. We need to look at the data properties and we need to understand the situation, and then accordingly we need to choose the right measure. So here, ideally, we can suggest that the shopkeeper should, when he plan his inventory, so he should give more importance to 8. Yes, of course, along with the size 9 and 10. So as a quick tip, if we look at, so let's understand, or can you answer my question of which measure can be used to budget, which measure can be used to measure, budget the expenses like food and electricity consumption in the household every month? Suppose I want to understand what is my expenses, or I need to actually plan it for my next month. So I have last 1 year data with me. So out of mean, median, or mode, which measure can be used for this purpose? So electricity consumption or food or groceries, I'm spending a lot. So how much should I spend for my next month? So should I use mean or median or mode for this? If we look at this kind of data, it's not varying much. Every month, if I take majority of the time, our consumption is going to be in a symmetric pattern. So we can say that in such cases, we can use mean to budget such things. Our expenses like food expenses or electricity consumption. So rare chances are there for variation. So in such cases, we can say that arithmetic mean is a good option for understanding the center value, or for modeling purpose, we can say we can go for arithmetic mean. Now, which measure can be used to categorize the items and tools used in a house to help you organize the household? So here, if we look at the things which can be organized, or maybe most frequently used items, can be grouped together, and that can be placed in a reliable place. So in that way, we can organize the house. So in such cases, the idea of mode is coming into picture. Okay. In such cases, or such categorical data is there with us, always think about model aspect. Mode as a good measure. So in short, as a thumb rule, I can say that if the data is numeric or check whether the data is numeric or categorical first. If the data is categorical, think about mode. And if the data is numeric, then you need to understand whether data is symmetric or asymmetric. So certainly a box plot can help us in this matter. So go for a visualization of data. Then if the data is symmetric, go for mean. And if the data is asymmetric, median. And still if you want to use mean, if the data is asymmetric, and if you want to go ahead with mean, then treating the data is very important. So then you need to treat, if outliers are there, you need to treat it, and then you need to group the data in such a way that the skewness or asymmetricity there in the data can be reduced. And then only think about arithmetic mean, and then let us move ahead with arithmetic mean. Because many of the data, many of the statistical analysis or models, if you go for ANOVA model or regression model or any t-test or any other hypothesis testing, basically majority of the test needs normality as an assumption. So that means basically all these things are based on arithmetic mean. So in such cases, you need to treat your data and then consider arithmetic mean as the central measure. So I would always say to use one measure alone is like looking through a keyhole. The part of the room you can see, but you cannot give a look at the entire room. You will not get a full idea of the whole room. So always understanding the measure through one measure, understanding the data through one measure is not enough. Okay, always keep that thing in your mind. Now, let's have a quick look at, just let me check the time. Okay, 10 minutes more is there. Let's have a quick look at when to choose range, interquartile range or standard deviation. How do we understand when should we go for range, interquartile range or standard deviation? So whenever your data is numeric in nature, okay, whenever your data is numeric or nominal or categorical in nature, in that case, all three measures of dispersion, that means whether it's range or interquartile range or standard deviation, is meaningless because all these measures need numerical values. Okay, so in such cases, you don't have to think about the dispersion there in the data because the data is categorical in nature. So we can't actually go for dispersion. And if you look at ordinal data, the range and interquartile range are the options. Interquartile range is usually preferable as it is more informative than the range. Why? Because it doesn't include any kind of outliers. It's beyond the, it doesn't include that part. It's between Q1 and Q3, the middle 50%. If you remember the box plot, it's within the box. Therefore, interquartile range is preferred in such cases. And if you have interval or ratio scaled data, in that cases, actually, you can all three measures you can look at. Either it can go for mean, median, or mode. But if in such cases, first you have to see whether the data is symmetric or not. If that means symmetric data, then you go for arithmetic mean, because that is what most of the statistical analysis need. And if data is asymmetric, then you must actually then you can't go for arithmetic mean, then standard deviation is not an option. So whenever your data is normally distributed, or when you choose central tendency as arithmetic mean, standard deviation is an option in such cases. Okay, and standard deviation is not appropriate when there are extreme score or skewness there in the data set. In such situations, the quartile range is usually preferable. So by this, let me conclude. So we can say that arithmetic mean or median or a mode, or choosing the central measures or measures of dispersion, whenever you look at the data, always do not consider as a single measure. Whenever you start with modeling the data, all the measures are important. Look at all the measures and then accordingly see the distribution of the data, and based on that, choose your central measures as well as measures of dispersion. Having said this, let me thank you everyone. And in case if you have any questions, I'm open for taking the questions. So let me stop sharing the screen now. Yeah.
Thank you, ma'am. It was really an interesting session. Thank you for giving us your valuable outputs on the topic Introduction to Descriptive Statistics and Measure. Dear participants, the feedback link will be shared in the chat box. Kindly ensure that you fill the same. Gratitude is not only the greatest of virtues, but the parent of all the others. I now take this opportunity to extend our gratitude to the resource person, Dr. Sinimole, Area Chair, Business Analytics, Rajagiri Business School, Kochi, for sharing her valuable insights on the topic Introduction to Descriptive Statistics and Measures. Thank you, ma'am. I now take this opportunity to thank Dr. Madhu Dhruva Kumar, ma'am, HOD, Head Department of Commerce, PG, for her constant motivation to scale greater heights. Thank you, ma'am. I would like to thank Dr. Cherian Thomas, FDP Coordinator, for the support. Thank you, sir. I would also like to thank all the participants for such an amazing audience and making this event a success. Thank you, my dear participants. It's my duty to thank our department faculty members, Dr. T.K. Murugeshan, Dr. Pushpa A., Dr. Vidya S., and Dr. Mohan Kumar. Their assistance for the conduct of this event is appreciable. Thank you, dear teachers. My deep sense of gratitude to the students of first and third MCOM and MCOM FA for being part of this program. Thank you, dear friends. I also convey my gratitude to the non-teaching staff, especially the tech team, for their efficient support throughout the event. Thank you, tech team. Dear participant, tomorrow session will start at 3:30 p.m. Kindly ensure that you join the same day. Thank you. I remain.
Thank you so much, Sinimole ma'am. It was a very interesting